So welcome to today's lesson. We're starting chapter 1, and we're going to look at greatest common factor and least common multiple. So at this point, you should know what a factor and a multiple are, that the factor is kind of what you multiply together to get that number as an answer, and the multiple would be when you're counting up by that number. So we're going to be able to look at two numbers and find their greatest common factor and their least common multiple. So here's your vocab for today. Please make sure you pause this and go ahead and write it down in your composition book. So we have 4 words. First word is factor. Factor is a number or quantity that when multiplied with another produces a given number or expression. So for example, 2 times 4 equals 8. So in that equation, 2 and 4 are factors of 8 because I can multiply them together to get 8. Multiple is the product of one number multiplied by another number. So for example, when I'm looking at multiples of 8, now I'm looking at 8 times 1, which is 8, 8 times 2, which is 16, and I could keep going. Those are multiples of 8. Now, we can look at something called greatest common factor, which is the greatest number that is a factor of 2 or more other numbers. And then least common multiple is the smallest positive number that is a multiple of 2 or more numbers. Okay. So we're going to look at 2 different ways to be able to find both GCF and LCM. You'll hear me call it that. They're kind of shorthand. GCF is shorthand for greatest common factor. LCM will be for least common multiple. I'm going to show you each way, but what I want you to do is pick the way that you like the best. Okay. So, split it in half here. I'm going to start with prime factorization. So, prime numbers are numbers that only have factors of 1 in itself. Okay. So, like 2, 3, 5, 7, 11, numbers like that. So, if I want to find greatest common factor of 2 numbers, I can use something called prime factorization. So, I'm going to make a factorization tree. So, let's start with 20 and 28. We want to find GCF of these two. So what I would do is I would make a factor tree for each number. So for 20 and 28. So it means I'm breaking it down into what can I multiply together to get those numbers. So for 20, for example, I could break it down into 2 and 10. You could have done 4 and 5. Also, there's nothing wrong with that. But 1 and 20 isn't getting you anywhere. It's just going right back to breaking down 1 and 20. Well, you need to break 20 down to begin with. So you don't want to use 1 and that number because that doesn't make any sense. You're just kind of making your work a little longer. So 2 is prime, so I stop there, but 10 I can break down because it's composite. So 10 can break down into 2 and 5. 2 and 5 are both prime, so the prime factorization of 20 would be 2 times 2 times 5. Okay, so for 28, I can break that down into 4 and 7. 7 is prime, and then 4 breaks down into 2 and 2, both of which are prime. So the prime factorization of 28 is 2 times 2 times 7. So what I want to look at now is I want to look at what factors do each number share? So I look at both lists. I have a list for 20, a list for 28, and I look for numbers that they both have. Well, there's a 2. They each have a 2. And each time I circle a pair, I'm going to write that number down as 1. And then there's another 2. That's another pair. And what I do is I multiply each pair. There's a 5 here, but no 5 here, so I can't use that. And there's a 7 here, but no 7 over here, so I can't use that. So all I have to do now is 2 times 2, which is 4. And I've got my greatest common factor between 20 and 28. Okay, so that's one method. The other method is called the cake method. It also can be called the grid method. Depends on where you're looking and who you're talking to. So what I do is I'm going to take 20 and 28, and I'm going to kind of put them, and you'll see this kind of go both ways. It could go underneath, or it could go over top, but the method's still the same. So what you think about is, what could I divide 20 and 28 by? Okay, so kind of like, what factor do they share? Well, they're both even, so I could divide out of 2. So I put 2 out front, and then I just do 20 divided by 2 is 10. And 28 divided by 2 is 14. And then now I have 2 new numbers, 10 and 14, and I do the same thing. You can see I take out a 2. Maybe 10 divided by 2 is 5. 14 divided by 2 is 7. And I do the same thing here. 5 and 7, what do they have in common? Well, they don't have anything, just a 1. So now what I do is I take those numbers out front, I take that row, and I multiply those together. 2 times 2 is 4. 4 times 1 is 4. And there's my GCF. Okay. Each method is going to give you the same exact answer. It's just kind of like a preference thing on which one you want to use. So let's look at another example of finding the greatest common factor of something. Let's look at the numbers 12 and 15. Again, I'll show you both ways, prime factorization or cake method. You are allowed to choose whatever makes the most sense for you. So for prime factorization, basically I'm breaking these down into factors. Okay, hence the word prime factorization. So 12. You think, what can I multiply together to get 12? Okay, you have 2 different options here. You can put 2 and 6 or 3 and 4. It really doesn't matter. That's kind of a preference thing. I'm going to put 2 and 6. 2 is prime because our goal is to get down to prime numbers. And then I have to break 6 down because that's not prime. And that breaks down into 2 and 3, both of which are prime. So my prime factorization would be 2 times 2 times 3. Now I look at 15. Okay, 15 I can do 3 times 5. And those are both prime. So I just have 3 times 5. And what I want to now look for is pairs. Okay, so there are no 2's in 15, so I can't use any of the 2's, but each side has a 3, so that means my GCF of 12 and 15 will be 3. Okay. Now I could use cake method to do this, and that's where I just kind of list my 2 numbers, and I think, what can I divide out of both 12 and 15? Well, can't divide 2, and 15 only has 3 and 5, so if I take out a 3, I'm going to be left with 4 and 5. And 4 or 5 only have a 1 in common, so 3 times 1 will give you 3 as an answer. Okay, so basically you're just pulling factors out of your numbers and then doing a little bit of multiplication to figure out GCF. Now, if you remember, it did say in the definition of greatest common factor, you could have more than 2. So we will occasionally see that we have to find GCF and even LCM of more than one number. Or more than 2 numbers, okay? So, for example, if I had 6, 12, and let's say 24, okay? Again, prime factorization would work as you factor out each of them, okay? So 6 would go to 2 and 3, 12 is going to go to 2 and 6, 6 is going to go to 2 and 3, and then 24 is going to go to 2 and 12, 12 goes to 2 and 6, 6 goes to 2 and 3. And now what I'm looking for is pairs between all of them, okay? So it has to have that number in all 3. It counts as just 1. And then they all also have a 3. So do 2 times 3 to get 6, okay? In cake method, I'm looking for a factor I can take out of all 3 for GCF. Okay, so I can see they're all even, so I take out and divide out a 2 out of each. So I have 6 divided by 2, which is 3. 12 divided by 2, which is 6. 24 divided by 2, which is 12. 3, 6, and 12, they all share a common factor of 3, so divide each by 3 to get 1, 2, and 4. 1, 2, and 4 don't have anything in common other than 1, so I take this row right here, multiply them all together to get your answer of 6. Either way you do it, you're going to get the same exact answer. Okay? So, GCF, okay, you're looking kind of, if you look, it's just that first row out front. Alright, now let's move on to LCM, which is least common multiple. Okay, again, you can use either method. In my opinion, cake method is actually a little bit easier than prime factorization because now prime factorization is going to have some rules. Okay, so let's look again. Let's look at 12 and 20. Okay, so I want to find now instead of GCF, I want to find LCM. That's my least common multiple. So really what I could do is I could sit here and list out the multiples of 12 and 20. So I could list 12, 24, 36, 48, 60, okay, and then do 40, 60, and now notice that, oh, the first number I hit that's the same as 60. That's great. But when you get bigger numbers than 12 and 20, say I had 125 and 300, I could be sitting here all day trying to figure out what the LCM is. So there are some easier methods to figure out what the LCM is rather than actually counting up with the multiples. But please realize that that is a valid method. It just may take you a long time. So what I could do now is prime factorize. So we're going to break it down into factors. So 12 breaks down into 2 and 6. 6 is not prime, so I'm going to break that down into 2 and 3. 20 can break down into 2 and 10. 10 breaks down into 2 and 5. Those are all prime. Okay. Now here's the difference. I am not looking for pairs anymore. I'm looking for the numbers that appear, and I want to write it the most times they appear in a list. So what I like to do is I say, okay, I see a 2. There's a 2 here too, also. How many times does 2 appear in 12 lists? 1, 2, and it appears twice here. So that means 2 times is the most it appears. So that's what I'm going to use. 2 numbers multiplied together. I also see a 3. There's not a 3 over here, but that doesn't matter. So the most amount it appears in a list is once. Same with 5. That's once. So that's the most. Now I multiply all those together. You get 4, 12, and 60 as your final answer. So you're looking for the most number of times it appears in a list. And that's how many times you will list it when you're finding the LCM. Okay. Kick method is a little bit easier. Okay. So we're looking for, this is the other way it'll be written when you're doing a kick method. It'll kind of look like a grid. That's why I said earlier it's also called grid method. Still the same concept. You're going to take out a common factor between 12 and 20. You may see that you can take out a 2 because they're both even. You may have also seen you can take out a 4 because they share that, and that's absolutely fine. As long as it's some factor they share, you're good to go. So 12 divided by 2 is 6. 20 divided by 2 is 10. So now I'm looking at 10 and 6. So I'm looking now just at this row right here. I know I'm asking what can I divide out as 10 and 6. You can see they're both even, so you can take out a 2 again. So I'm going to do 6 divided by 2, which is 3, and 10 divided by 2, which is 5. Now I have a new row, 3 and 5 here, and I ask myself, what do those numbers have in common? Well, 3 and 5 only have a 1 in common. Okay, so before in the cake method when we were doing GCF, we just kind of took this first row out front, we multiplied it together. But now we're talking about LCM. So what I'm going to do is I'm going to take and look for the L, and I'm going to circle that, and those are the numbers I'm going to multiply together, get an LCM. So I do 2 times 2, which is 4, times 1, which is still going to give me 4, and then 4 times 3, which is 12, and 12 times 5 to get 60. Either method will still give you the same exact answer. This is all just a preference thing. Okay? Let's try another example. Let's do 9 and 15. Okay. So again, I could do prime factorization, so break it down. 9 breaks down into 3 and 3. 15 breaks into 3 and 5. As you can see, we see the number 3 in both lists. So what I want to do is look at each list and see what's the most amount of times it appears in a list. So over here on 9, it appears twice. Over here on 15, it only appears once. So the 2 is bigger than the 1. So I'm going to use 3 twice. Okay. And then there's a 5. So that's the most it appears. So I would have 3 times 3 times 5, which is going to give me 45. That's what I see. I'm looking at cake method again. So here's the other way we could draw it. I'm still just asking myself, what can I divide out of 9 and 15? I could divide a 3 out of both. So 9 divided by 3 is 3. And then 15 divided by 3 is 5. They have a 1 in common now. And again, still looking at the L shape right there. And then multiply those all together. 3 times 1 is 3. 3 times 3 is 9. And 9 times 5 is still 45. Doesn't matter which method you use again, it still will work. And just like with GCF, you can have 3 numbers. It just gets a little bit more complicated with LCM. So let's do 5, 18, and 30. And let's find the LCM of these guys. Okay, prime factorization, pretty straightforward. Again, I just want to break it down into the prime factors. Well, 5 is already a prime factor. I don't have to do anything to it. 18 breaks down into 2 and 9. 9 breaks down to 3 and 3. 30 is going to break into 2 and 15. 15 out into 3 and 5. Okay, so now I look at the list and I see what numbers appear and what's the most number of times they appear in the list. I see a 2. It appears here and also here. And it only appears once. That's the most amount, so I'm going to use it only one time. Now I look again. I see a 3. I see 2 3s here, 1 3 here. 2 is bigger than 1, so I'm going to use these 2 3s here. So I'm going to do 2 times 3 times 3. And then I look and I see, oh, there's a 5. There's 1 5 here, 1 5 here. So the most number of times it appears is 5 times. So I'm going to multiply those together. 2 times 3 to get 6. 6 times 3 to get 18. And then 18 times 5 to get 90. So 90 would be my LCM. Cake method gets a little bit more complicated when I'm finding LCM of 3 numbers. Because before with GCF, you were taking a factor out of all 3, so I would have to have a common factor between the 5, the 18, and the 30. But for LCM, that's not the case. You're looking between 2 numbers at a time. So for example, I can look between 18 and 30 and see that they share a 2. So I'm going to take that 2 out. And then what happens is I don't do anything with the 5 because I was just focused on this 18 and the 30. So 5 stays the same. Now I divide the 2 out of the 18 and the 30. Okay. And then I can look at the 5 and the 15 and see, oh, hey, they share a 5. So I just divide a 5 out of the 5 to get 1. 9's going to stay, and then the 15 divided by 5 is going to give me 3. Now I'm going to see that 9 and 3 share a common factor, which would be 3. So I'm going to keep the 1, because I didn't touch it, divide 9 by 3 to get 3, and divide 3 by 3 to get 1. Now, there's nothing else in common down here. So, again, I'm still looking at the L shape. And I'm going to multiply all this together. And as you can see, it's kind of the same as what we did over here. We got 2 times 3 times 3 times 5. And then the 1s, when you multiply those in, they're not going to change anything. So, I'm still going to end up with an answer of 90. This one's just a little bit more complicated because you're only looking at 2 numbers at a time for LCM when you have 3 numbers rather than all 3 of them at once. Okay. So now that you've had some examples, I want you to check out pages 8 and 10 in your math journal. Make sure you complete all the got it questions in your journal. Okay, so that's like your A, B, C, D when we see those. And then what you're going to do is you're going to go to Schoology and you're going to check yourself on those answers. So you're going to solve them in your book and then you're going to Schoology and you'll see there's a check for understanding and you're going to put your answers in. You're allowed to do that multiple times until you get a good score. That way, you feel a little bit more confident, you're getting more practice. And then what you want to do is follow the rest of the directions on Schoology. Please, please, please ask me if you have any questions whatsoever. I am here to help. I'm going to come around the room, answer any of the questions you have once I'm done teaching the mini lesson that I'm doing with some of the kids. Okay? So make sure you're asking me questions, ask other people questions, and you can even Google stuff yourself for extra help and extra videos and things like that. Okay? So you need to realize, you guys have all the resources you need right at your fingertips to help you understand better. All right? Have at it.